whatever we are gonna say. Today we will start our highway engineering course MCQs, and let's begin with that. So first of all, I will start with the question number 2. I'm randomly starting the questions, it's no problem. So the minimum value of Camber provided for thin bituminous surface hill road is. Now what is Camber, right? असल में हमारे साथ जो सड़कें होती हैं वो फ्लैट नहीं होती, मतलब सड़कें बाज़ार दिखती फ्लैट है लेकिन फ्लैट होती नहीं। मतलब अगर मैं यहाँ पर भी देखूँ इस इमेज में, ये सड़क फ्लैट दिख रही है, ये हाईवे है, लेकिन ये है फ्लैट नहीं, ठीक है, फ्लैट नहीं है। दिखती तो फ्लैट है लेकिन फ्लैट नहीं है। तो अगर यहाँ पर भी मैं देखूँ, ये देखो, ये स्लोप दिया हुआ है, ठीक है, इसी तरह यहाँ पर भी स्लोप दिया हुआ है। देखिए इस स्लोप की वजह से यहाँ पे मेरे साथ इस तरह की फॉर्मेशन बन रही है, ठीक है, कुछ इस तरह की फॉर्मेशन बन रही है। मैं आपको दिखाता हूँ वाइट बोर्ड में। इस तरह की फॉर्मेशन जब आपके साथ बनती है तो ये किसकी वजह से बनती है? स्लोप की वजह से बनती है, यानी ड्रेनेज को सपोर्ट करने के लिए। इधर से भी पानी, अगर बारिश का पानी, बारिश आता है ऊपर से, ठीक है, तो कुछ पानी इधर से जाएगा, इधर से जाएगा। तो यहाँ पे साइड्स पे हम साइड ड्रेन्स बनाते हैं। अक्सर हम देखते हैं सड़कों पे इस साइड पे ड्रेन होते हैं, बीच में हमारे साथ बीच में जो हमारे साथ जो लैंडस्केपिंग पोर्शन होता है, ठीक है, तो जो साइट होता है बीच में दो सड़कों के बीच जो बैरियर होता है, तो जो डिवाइडर होता है, तो उस डिवाइडर या जो साइड में हमारे साथ जो लैंडस्केपिंग पोर्शन होता है उसमें यहाँ पे स्लोप बनते हैं। अक्सर यहाँ पे जो हमारे साथ जो साइड पाथ होता है सड़क के साथ, यहाँ पर भी हमारे साथ अक्सर स्लोप के लिए ड्रेनेज हम बनाते हैं, ठीक है। जो बेवकूफ़, नालायक और स्टूपिड इंजीनियर्स होते हैं, और जो दो टके के ठेकेदार होते हैं, वो तो इस चीज़ पे फ़र्क ही उनको नहीं पड़ता। उनको खाली सिर्फ अपने पैसों से और इंजीनियर्स को अपने कमीशन के साथ मतलब होता है, ठीक है। तो सरफेस जो है, सरफेस इज एंगल टू स्टॉप। सरफेस को हम एंगल में बनाते हैं, जिस तरह मैंने थोड़ी देर पहले कहा कि मतलब हम क्या करते हैं, इस तरह एक सरफेस होती है, ठीक है, तो उसको हम एंगल्स में बनाते हैं, इस तरह एंगल लेते हैं, ठीक है, राइट। कुछ एंगल यहाँ पर इस तरह बनेगा और यहाँ पर भी थीटा मेरे पास बनेगी, ठीक है। तो कुछ थीटा यहाँ पे, कुछ थीटा जो है एंगल यहाँ पे मेरे साथ बनेगा। इफ लेट मी आई राइट दैट, तो यहाँ पर भी मेरे साथ थीटा बनेगा, ठीक है, और यहाँ पर भी मेरे साथ एंगल बनेगा, ठीक है। तो ये भी एंगल है, ये भी एंगल है। तो सरफेस को हम एंगल करते हैं टू स्टॉप रेन वाटर, ताकि इस पे अगर बारिश का पानी आए तो वो इस पे ना पड़े बल्कि साइड ड्रेन्स में जाए। एंड स्नो मेल्ट गैदरिंग इनटू पडल, जब इसमें बर्फ़ पड़ती तो वो सड़क की सरफेस पे घुस जाती है, ठीक है। मैं आपको दिखाता हूँ। एज यू कैन सी इन दिस केस द स्नो इज falling down on the surface of the road. So this is a dividing line, and this is a one-way road, but it is two planes, it is two lanes. It's a one-way two-lane road. There is a one-way one-lane road, there is a one-way two-lane road. The traffic which are moving in this direction will go in this direction, and if traffic is going in this direction, will go in this direction. In Pakistan, we follow Pakistan standards. In Pakistan, we are going always going towards the left side whenever we are going towards a special destination or special area where we want to go, and our steering wheel is always on the right side. So that is why the passenger seat is always on the left side. But in the foreign countries like America, the United States, the passenger seats is on the right side. If even we are going in this direction, and the driver's seat is on left side, so they're always seating on the left hand side whenever they're going towards a destination and rotation. So if we are going in this road in Pakistan, so and in foreign countries or developed countries, they are going in this direction, with the driver's seat always on the left side, even though if they are facing this dividing line with the left hand side, so they will go. And if Pakistan over here going in this direction, so in a US or in foreign countries or western countries, they are always going in this direction, the driver's seat always on the left side, the passenger seat always on the right side, while in Pakistan it's always the opposite case. So in this case you can see the snow fall. So in this case the snow is putting on the surface of the water on the road. So the snow is putting on the surface of the road. So what happened? So if there is no camber provided in the road, the snow will not gonna melt. The snow will stay in the road and the vehicles will slip down. You will use the technology of steel chains, and foreign countries the steel chains by the plastic chains. Steel chains are replaced by plastic chains, and there's a new technology that are being wired to the tires assembly overall, and then the vehicles are not slipping. But despite the fact that why to take such accident, there must be a slope provided on the roads camber to that, so that the snow can melt and then gathering into puddle and it will remove, right? So whenever we are providing a camber, so that slope will be in a slope will be 2.5%. This will be the slope 2.5%. It must be given to the in the hills, right? Like for example, if we have road in a hill, so if that is a road, if I can clear in the picture, so if that is a road, so what kind of camber will be provided? And camber will be provided in percentages. So what kind of camber will be provided in that? So 2.5%. As you can see, in this is another road in a hill, which is the recommendations to provide the camber 2.5%. So in this case, if I can look at in this case here, there is a slope given. The slope is given. You can see, so that is given 2.5%. The recommendation is to give 2.5%. Here slope is given in this direction. It depends upon the engineers and how they design that, how it's given in the drawings or structural drawings, right? Or sometimes in structural notes or architecture notes, depending upon the consultancy system, the designing systems, depending upon the client drawings. But whatever, the slope is recommended to provide 2.5% out of 100%. And hell, why we provide camber in road? That's a homework for you guys. So it will depends upon that. So so you guys have never been doing anything right. You guys are not being able to comment here, write down, and this my questions task I given to you, but it's once again a task I'm given to you, so you guys to comment in a comment box that why we provide camber on the roads. Recommendation is 2.5%. Why we provide camber on the road. This is another road leading in a hill, so 2.5%. Whether typically it's been providing like in this direction 2.5%, 2.5%, maybe 2% depending upon the structural notes, right? Depending upon the designer, the road designer. But if that's 2% or 2.5%, but recommendation is 2.5% to provide camber in a hill road, right? So in a straight road, how much camber is provided is another homework for you. And why we provide camber on a roads or hill road, that's another homework for you. Write down in the comment box and the combo box, right? So what is thin bituminous road? Thin bituminous road, as the name shows, that the bitumen thickness will be thinner. How much? That's another homework for you, task for you. So as you can see, a coin is put it, a coin have how much depth? A coin is put it in this bituminous asphalt, and what happened that it's resting in this bituminous road. So it means having a lesser thicknesses known as thin bituminous road. Like in this case, the bitumen thickness is thinner, it's a thin bituminous road. In this case, the bitumen thickness is thinner, it's thin bituminous road. A bituminous road is a bituminous sealed road having a bituminous provided on that, sealed on that is a layer of bitumen sprayed, and a bitumen layer is being sprayed and then covered with an aggregate, and then provide it aggregate, so it's aggregate based course, right? This is then repeated to give a 2-coat seal, then 2-coat seal has been provided, asphalt is produced, in this case asphalt in a plant that heats, and then it's dries, and then we laid that asphalt on and mixed aggregate, bitumen and sand into a composite mix, right? So it's a bituminous road having a bituminous layer provided to it, with a covered with an aggregate, and then 2-coat seal is being provided, and then when asphalt is produced, a plant that has been laid over, then it's called asphalt wearing course when it dries, right? And also mixed of aggregates and bitumen, right, and sand and a composite mix, right? So when we are providing a concrete and thick bitumen road, then the camber might be 2%, 1.7% to 2%, right? That's been taken from all around suggestions. In thin bituminous road, we provide 2.5% camber as we studied in the MCQ, but that is in a hill. But otherwise, like if you are providing camber and thin bituminous road, then having a camber 2%, 2.5%, and water-bound macadam road, we will discuss in the future tutorials, and we will make a separate video on that, right? But water-bound macadam road, WBM road, we provided camber 3% to 2.5%, 2.5%, and then in earth road we provide camber to 3% to 4%. That is taken from suggestions. Let's discuss some more suggestions. Then there's regions where rainfall occurs a lot of, and some regions there is no rainfall, and there's some regions there are light rainfall. So it's a types of camber provided in a road. We have 4 types of road: high bituminous road, we have a thin bituminous road, we have a water-bound macadam road, or we have a gravel road, and we have an earthen road. So where if there is a light rainfall in a high bituminous road, a camber is 1.7% provided out of 100%. Where there is a heavy rainfall region where rainfall occurs in abundantly, in most abundance, we provide camber 2%. In a high bituminous road where rainfall occurs so frequently, we have then a thin bituminous road, as we discussed in the question, where rainfall occurs lightly, and area where it's a thin bituminous road, and the region where rainfall occurs lightly, we provide camber 2%. But where a rainfall occurs mostly in a thin bituminous road, where it's provided in a region and where thin rainfall occurs in a heavy manner, then we provide 2.5% camber and a thin bituminous roads. So I will always remember these questions in my painful heart, always. And you gotta have to remember, and remember me for my good health, and that I am giving you skills of your life. And we have a water-bound macadam road, or which is also called the gravel road, where rainfall is light at that region or occurs sometime. We provide camber, our slope, a gradient 2.5%. These 3 are the same name. However, we have a water-bound macadam road, a gravel road, where rainfall occurs so mostly, we provide camber 3%. For the last, not certainly the least, with an earthen road, where we provide a rainfall, it's occurring lightly, we provide camber 3%. And for heavy rainfall, we provide camber 4%. It means that the camber in one of the cases not greater than 4% or not smaller than 1.7 or 1.5%. So that's another MCQ. So that's a water-bound macadam road, WBM road. It's also called gravel road because these gravels are laid and Pashto is called roda. So these gravel are laid on this road. So it's called waterbound macadam road. Another picture is, you can easily see in the picture to the left is preparation of subgrade. We will discuss one by one the road structure, road details, a cross section of a road, and some other tutorial or vlog. But in this case, a road to the right is laid after preparation of subgrade is by gravel, right? So we have a sub base, we have a subgrade, then base course, then sub base, then base course, or sometimes called aggregate base course, which you are seeing in this case, in this image, aggregate base course. So also called the gravel road, right? It's also another picture of gravel road, a waterbound macadam road, and that's one of the example of an earthen road, right? Design of horizontal and vertical alignments, super elevation, side distance, and grades is worst affected by. You can see grades. These grades are Camber, which we studied a few minutes earlier. So the correct answer is option number D, the speed of the vehicle. But how? So what is design of horizontal and vertical alignments? Let's discuss the first horizontal alignments. As you can see in this image, that's a horizontal alignment, right? And that's a vertical alignment. In this case, it's a horizontal alignment plan view, right? So it's a plan view, like in this is x-axis and that is z-axis, right? It should be y-axis, but it's written z-axis. So if you can see, there's a road going in horizontally. That's a top view, and it's a vertical alignment. It's a profile view where this is coming in a slope and then going towards a little bit upward. So when up and down behavior occurs in an alignment, that is a vertical alignment of road, right? You can see it's a ground profile, and that's an intersection point, right? There we go, this point, and this is a vertical alignment. So alignment is how you align the road, but if that is horizontal, it's a horizontal alignment, and if that's vertical, it's a vertical alignment. It's a horizontal curve, and that's our horizontal alignment, right? Simply, if you horizontally align the road, that is called horizontal alignment. Okay, I mean the horizontal alignment of road is defined in terms of if I can in terms of what, a straight line, right? Have a straight line, okay, and straight line tangents, and then of course horizontal curves, okay. Then the curves allow for a smooth transition between the tangent sections, right? यानी इसमें हमारे साथ क्या होता है, इसमें हमारे पास स्ट्रेट लाइन होती है, स्ट्रेट लाइन टेंजेंट्स होती हैं, और हॉरिजॉन्टल कर्व्स होते हैं हॉरिजॉन्टल अलाइनमेंट में, ठीक है. I have always remembered this thing in my entire life. These are my skills. That is, I am giving to you. That I always remember in interviews. Whether selected or not, I always remember that straight lines tangents is a horizontal alignment through straight line tangents, and then horizontal curves, and the curves allow for smooth transitions between the tangent sections, right? तो आप लोगों ने भी यही याद रखना है कि इसमें हमारे साथ जो कर्व्स होते हैं वो अलाउ करती है, वो इजाज़त देती है स्मूथ ट्रांजिशन के लिए between a tangent section. और circular curves and spiral are two of horizontal curves. इस पे दो horizontal curves utilized to meet the various design criteria. Now what is horizontal vertical alignment of roadway? तो जो vertical alignment है या उसकी प्रोफाइल है, उस पे हमारे पास होता है at the point of super elevation rotation. उस पे हमारे साथ super elevation rotation आती है, और ये पॉइंट जो है इट इज़ नॉट अफेक्टेड बाय द चेंज इन एलिवेशन, ये एलिवेशन की वजह से ये इस पर अफेक्ट नहीं आते व्हेन द रोड इज रोटेटेड बाय फॉर हॉरिजॉन्टल कर्व, राइट। मतलब अगर हम देखें तो ये वर्टिकल अलाइनमेंट है, ये रोड इस तरह वर्टिकली अलाइन हुई है, ठीक है, या इसमें अगर हम इस तरह ये नीचे गई है फिर ये ऊपर हो गई, जिसको वर्टिकल अलाइनमेंट कहते हैं, ठीक है। इसमें हमारे साथ जो कर्व्स होते हैं आर यूज्ड टू प्रोवाइड अ ग्रेजुअल चेंज, मतलब ये हमें ग्रेजुअल चेंज देते हैं, ठीक है। मतलब जो कर्व्स होते हैं ना हमारे साथ, ठीक है, वो क्या करते हैं, वो यूज ग्रेजुअल चेंज देते हैं, ठीक है, फ्रॉम वन टेंजेंट ग्रेड टू अनदर, एक टेंजेंट ग्रेड से अनदर टेंजेंट ग्रेड तक, ठीक है, एंड सो दैट द व्हीकल में स्मूथली नेविगेट चेंजेस एंड ग्रेड, ताकि व्हीकल्स जो है वो आसानी से क्या हो सके, आसानी से जो है वो नेविगेट कर सके एंड ग्रेड एज ए ट्रेवल द हाईवे, राइट। अच्छा, साइड डिस्टेंस हमारे पास क्या होता है, ये एक्चुअली एज ए लेंथ ऑफ अ कैरिज वे दैट इज विजिबल टू ड्राइवर, यानी वो लेंथ जो ड्राइवर को आंखों से दिख सकी, तो उसको हम साइड डिस्टेंस इज डिफाइन, इसको हम इस तरह डिफाइन करते हैं। और जो कम से कम साइड डिस्टेंस है शुड बी सफिशिएंटली लॉन्ग टू इनेबल अ व्हीकल traveling at or near the likely top speed to stop before reaching on object in a spot। और कम से कम साइड डिस्टेंस वो होता है जो कि एक ड्राइवर को मतलब इस काबिल बना दे कि वो अपनी गाड़ी को दूसरे ऑब्जेक्ट के आने से पहले वो रुकवा सके। देखिए, ये जो स्पेसिफिक जुमला है, जो साइड डिस्टेंस है, कम से कम साइड डिस्टेंस वो होता है should be sufficiently long to enable a vehicle traveling at or near the likely top speed to stop before reaching an object in spot। मतलब किसी शे के रास्ते पर पहुंचने से पहले या उसके करीब सफ़र करने वाली गाड़ी या उसके करीब सफ़र करने वाली गाड़ियों को ज़्यादा रफ्तार रोकने के काबिल बनाना। मतलब ज़्यादा रफ्तार रोकने से अपने आप को काबिल बनाना ताकि दूसरे गाड़ियों के साथ टक्कर ना लगे, दूसरे शे के टक्कर से पहले अपनी गाड़ी को स्टॉप करना, इसको कहते हैं साइड डिस्टेंस, ठीक है। देखिए, ये एक रोड है, ठीक है, इस रोड इस पे गाड़ी जा रही है। देखिए, इस गाड़ी को इस रोड से ऊपर की तरफ जो फोर्स खींचती है उसको सेंट्रीफ्यूगल फोर्स कहते हैं, ठीक है। ये फोर्स जो है ये इस गाड़ी को इस डायरेक्शन पे, इस सड़क से इस डायरेक्शन पे खींचती है। That is a centrifugal force, and that phenomena occurs in a super elevation, forces associated with super elevation that you guys never understand that, and that you guys never understand that, and never understanding that. I'm gonna give you that skills. Remember me in your prayers. So these are the forces associated with the super elevation. So the first force is the centrifugal force. But the force weight exert a force towards the center of the curve. Inside, the centrifugal force is outside. Inside, that is a centripetal force, which is this force acting a vehicle inside. Like this is a curve, so inside towards the center of the curve. This is the velocity which the vehicle is moving. This is the weight. This is the weight of this vehicle, and this is the friction, the lateral friction, side friction or lateral friction of the vehicle. So these are the forces associated with the centripetal super elevation. That is an image taken from my very good friend Suleiman Khan, SLK Toots, our engineer boy. So super elevation formula is breadth. We need to know about the breadth of the vehicle, which is in this case 8 meter wide, the breadth of the highway. The velocity which the vehicle is moving, which is 50 kilometer per hour. All right, and the G, which is the gravitational acceleration due to gravity, right? And of course R, the radius of the curve, which is 300-meter radius. So the formula is H is equal to B, breadth of the highway or road, multiplied by the velocity of the vehicle, which is in this case it's converted into meter per second. So we have find the H, which is the super elevation, that in a circular curve a road can be super elevated, or it can give to that depth or that height at one side. So that is 52.5, but according to the limits, so we have the formula for super elevation limit according to the taken from Suleiman Khan, and he is taking it from books. He's not that guru, genius. Of course he's taken from the books. He's not a guru, but whatever, I'm taking the reference from SLK channel, engineered by. So that is one, you have to divide breadth by 10. The breadth of the road must be divided by 10. It gives you 8 divided by 10, 0.8 meter. It gives you 80 centimeter. This is the limit for super elevation, and he find it out of course 52.5 according to the formula. So the 52.5 centimeter is the provision of a super elevation and this circular curve road, right? So that's a concept of super elevation. Let's come back to the question, but I have done some calculation for you. I give instructions to Brinley.n, and 1 kilometer is 100,000 meter pertaining, 1 hour pertaining 3600 seconds including, so 50, and you have to kilometer. So for K I put 1000 and 1 hour 3600 seconds. So of course dividing, plug-in, check-ins, and put in, plug-in, check-ins, and all will put in and everything. It brings me down to the word. After all plug-in, check-ins, put in, calculations, mathematics, math, a little bit mathematics, it gives 225 by multiplied by 5 divided by 9. It gives you 12.5 by 9. 125 by 9 gives you 13.8 meter per second. Okay. So it's worst affected by the speed of the vehicle, not the height of the vehicle, not the length of the vehicle, not the width of the vehicle. Speed of the vehicle can affect worstly width of the horizontal alignment, vertical alignment, super elevation, side distance, and of course grades, cambers. Okay, so let's move to another question. The thickness of a vehicle, the thickness of pavement may be reduced considerably by compaction of soil, stabilization of soil, drainage of soil, combination of all of the above. So the correct answer is combination of all the above, right? But how that is correct? Now, why we compact soil? That's my first question. When we're preparing subgrade, the natural soil that is existing, we will discussing the zones of a road structure as well one day, inshallah. Just give me your prayers. I will do everything what you want, but just give me prayers. So the compaction of soil is necessary. Why? So we need to compact the soil for the preparation of subgrade, right? The natural soil that existing, we need to compact that. So for that we use soil compactors. In Pakistan it's called Dynapack, but it's called soil compactors. You can see this road, a roller has been a compactor, a roller we use to compact the soil. because this is a consideration, this is a requirement for preparation of a road, right? So